up, everyone? So this is an introduction to statistics for the psychological sciences. My name's Rob, and this is the second part of the 6th lecture. And in this lecture, we are going to go through the hand computation of a Pearson product moment correlation step by step. So without further ado, we'll just dive right in. Okay, so we left off in the last lecture with some conceptual information that feeds into how the basic equation for a correlation is going to work, right? And so we discussed what covariance was. It's the tendency for variables to overlap in how they vary, right? So variables can vary together, but there's also reasons that variables vary that aren't related to the other variable. And so, we use the example of if you were trying to assess how much exam performance covaried with how many hours of study, certainly there's going to be overlap. They're going to vary together for a variety of reasons, right? Studying is going to certainly explain differences in why people score what they do on the exam. But there's also other variables there's other reasons that test performance varies that isn't predicted by mere studying alone. So, for example, it might have something to do with the amount of sleep you got the night before, or IQ, or motivation. There's a variety of different things that could explain the variance in test performance that isn't the same variance as what studying would explain. And so we basically have the variance that our x variable explains in y, and we also have what's left, what doesn't vary, and what isn't shared variance. So you can see here that the R equation, the correlation, the Pearson correlation between x and y, the conceptual equation is it's equal to the degree to which variables vary together divided by the degree to which variables vary separately. So, this is a ratio. How much does this variable explain in units of what's left unexplained by that variable? Now, if they perfectly covary, right, then the numerator is going to equal the denominator, and it's going to be 1 or minus 1. So let's look at this equation, and we'll step it up a notch in terms of complexity. So basically, R measures the sum of squares between x and y over the sum of squares of x and the sum of squares of y. Let's unpack this even more. So it's getting scary looking, but okay. Think back to when we computed standard deviation. It's very, very similar, right? Like we're looking at the sum of the difference between each point, each raw data point for x, how it deviates from the mean. But in this case, we're looking at the deviation of x from its mean times the deviation of y from its mean, and then dividing by the deviation of x and the deviation of y. Now this was kind of remember with standard deviation, we had the conceptual formula, which we did by hand, but it would be very laborious to do that if we had a lot of data, for example. And there's an easier computational formula. And so this is what we're going to use to compute a Pearson product moment correlation. So it's essentially, we have the sum of the cross products minus a formula that describes the covariation of x and y divided by the formula for the variation in variable x and a formula for the variation in variable y. So essentially, this is how we're going to compute it, but we need to kind of set up the problem first. So I'm going to go ahead and fade out here, and we will go to the virtual whiteboard. Okay, so say we're presented with this data, right? So we've got 5 people, so we've got an N of 5, right? And the first thing that we're going to need to do is we're going to compute the sum of x and the sum of y. So if we add up these numbers, we're going to get 21 and 22. Then the next thing that we're going to do is we're going to square each x raw score in its own column and sum it. And then we're going to square each y raw value and sum them in their own column. So we'll make a column for x squared and a column for y squared. And so 1 squared is 1, 3 squared is 9, 4 squared is 16, 6 squared is 36, and 7 squared is 49. Easy peasy. Okay, y squared, 2 squared is 4, 5 squared is 25, 3 squared is 9, 7 squared is 49, and 5 squared is 25. When we sum them up, we're going to get 111 for x squared and 112 for y squared. Okay, and then the next thing we're going to do is we're going to compute the cross product of x and y. So this is just x times y. And so 1 times 2 is 2. 3 times 5 is 15. 4 times 3 is 12. 6 times 7 is 42. 7 times 5 is 35. And sum them all up, and it's 106. Okay, and so now we can kind of zoom in here. This was our formula, right? And we just need to plug in the values that we've computed into this formula. So let's do that. So R is going to be equal to the sum of x times y. And that's going to be this value right here, 106. So 106, and then minus the sum of x, which is going to be 21, times the sum of y, which is 22. And again, I'm getting those right here. Divided by n, which is 5. There's 5 people. And then we're going to divide this. And we need to figure out the formula for the variation in x. which is going to be the sum of x squared. So this can be tricky, right? Make sure that you're summing the squared values of x. So this is what we're going to get here. It's going to be 111 minus the sum of x, which is 21, squared. So 21 squared divided by 5. And then we're going to do the formula for the variation in variable y. And this is going to be same way, 112 minus 22 squared divided by 5. And then we need to take the square root of all of that. So you see, if you do this table first, it makes it a lot easier. It's just kind of plug and play, right? So this is going to work out to be 13.6 divided by 18.616. And this is going to be equal to 0.731, which is basically 0.73. And that is our Pearson product moment correlation. So it's really it's easy as that, right? Now we could do, if so R is equal to 0.73. One thing we might want to do in addition to this is to square R to figure out the proportion of variance in variable x explained by variable y, or you could say variance explained in y by x. So R squared, if you square 0.731, you get 0.5343. Actually 0.44 if you round. So that means 53.44% of the variance is explained. Okay, well, I hope this was, despite the fact that the formula looks a little scary, I hope this wasn't too tricky or challenging. It's very straightforward if you take it step by step and just make sure you don't accidentally compute the sum of x squared and the sum of x squared values wrong. And just follow order of operations and you're good to go. So correlations really aren't that challenging when you get down to it. Well, I hope this is helpful, and I will see you in the forthcoming lab video where we will do an example of how to compute Pearson correlations in SPSS. We'll also make scatter plots, and hopefully we might learn something. We'll be using some interesting real data. Okay, cool. Later.